So 45 grams of sugar is dissolved in 100 grams of water. What is the concentration in percent by mass? So we're looking for percent by mass again. Percent by mass, remember, is going to be equal to the number of grams of the solute. And so the solute here is sugar. And how many grams do I have? I have 45. So I have 45 grams of sugar divided by the mass of the solution. And so I'm told that I have 100 grams of water. Same problem I messed up on last time here. Water is not the solution, water is the solvent. To find the total solution, I'd have to say, add up the solute, sugar, and add up the solution, water. And so I'd say 45 plus 100 gives me 145. And so that's going to be the mass of my solution here. And then times 100 to get into percent. And so doing so, we go ahead and we take our guy, we say 45, then divided by 145, and then times 100. And so I get 31.03, 03%. Significant figure-wise, 45 grams, that's spelled out, so it's infinite significant figures. 100 grams of water, that's only at 1 sig fig. And so we'll round this to 1 significant figure. And so our answer is that this is a 30% sugar solution. And that's how you work that out. Let's try another one. How much barium sulfate must be added to 300 grams of water to produce a 45% barium sulfate solution? So we're going to use the same. It says that it's a 45% barium sulfate solution, and so we know the percent by mass in this case, 45. This is equal to the number of grams of solute. Do we know that? Well, it says how much barium sulfate. Barium sulfates are solute, so we don't know what that is, so we're going to call that just X up here, divided by the mass of the solution. Well, we have 300 grams, but that's 300 grams of water. That's the solvent, not the solution. And so to do this, we're going to have to say 300 plus X, because we have, in order to find the mass of the solution, we've got to add the mass of the solute, which is X, plus the mass of the solvent, which is 300 grams of water. And so this is what we have to start with. And then, of course, times 100, right? Times 100 up here. And so in order to get this to work, we're going to have to sort of solve here. We want to divide both sides by 100 first. That'll cancel out the 100 on over here on the right. I don't know what I'm thinking here today. So we're going to end up, we do that, we get 0.45. We're then going to want to multiply up the 300 plus X like that, and this is going to equal X just like that. So then going ahead a little farther here, we take out our calculators. Let's distribute the 0.45 through. And so when we do that, we get 0.45 times 300. And so I get 135 for that. So we get 135 plus 0.45x equals x. And so we want to subtract off 45 tenths x from both sides. So minus 0.45x. And so when we do that, we get 135 is equal to, 0.55x, because just x minus 0.45x equals 0.55x. Divide both sides by 0.55. Doing that, that's going to cancel out on one side our 0.55s right over here, and that should let us go ahead and figure this out. So we'd say 135 divided by 0.55. And I get 245.55. And so in this case right here, if we wanted to produce a 45% barium sulfate solution, I would need 45, in this case 0.5 grams. Significant figure-wise, 300 has one significant figure, 45 has two, so my answer should have one significant figure, which around it is 200 grams of barium sulfate, would be my final answer. So that's how you would use percent by mass to work out some basic calculations. So 4.5 liters of a 1.3 molar HCl, hydrochloric acid solution, contains how many grams of HCl? So first thing we know here is that we have the concentration. It's 1.3 molar. And so we're going to say 1.3 molar solution. This is equal to the number of moles of solute. And the solute here is the hydrochloric acid. And how many grams of that do we have? Well, that's what we don't know. It says how many of these. So that's going to be X. We don't know how many moles we have. Divided by the number of liters of solution, and it tells us we have 4.5 liters of solution. So we have 4.5 liters right there. And so to solve this, let's go ahead and get x. We want to multiply 4.5 on both sides. And so we get 1.3 times 4.5. And in doing that, I get 5.85. And so I have 5.85 moles of hydrochloric acid, HCl. But the question asked me how many grams. And so because it asks how many grams, I've now got to go take this 5.85 and do a conversion with it. And so I'm going to put it in my table, 5.85 moles of HCl. I'm going to put it in my table here. I want to cancel moles. I want to go to grams. And so you're going to need the periodic table for this, because anytime we convert from moles to grams, we use the periodic table. And for hydrochloric acid, hydrogen has a mass of 1.01. Chlorine has a mass of 35.45. So we end up with 36.46. 36.46 is what we get for our number of grams in a mole. So 36.46 is grams in 1 mole. And so moles HCl cancel. We go to grams. So we'd simply take our 5.85 times 36.46. And doing that, I get 213.291. Our answers, since we have things have two significant figures on both sides here, then we're going to end up with 210 grams of HCl, hydrochloric acid, would be our final answer. So if I have 4.5 liters of 1.3 molar solution, I had to add, or I have inside of that, 210 grams of hydrochloric acid. So another one. How many liters of a 0.45 molar barium chloride solution could be made with 1.1 moles of barium chloride? So in this case right here, I know the molarity to start with. I have a 0.45 molar solution, 0.45 molar. And so in this case right here, I know that's going to be moles of solute. My solute here is barium chloride. How many moles do I have? I have 1.1 moles. So I say 1.1 moles of barium chloride on top. On bottom should be liters of solution. And do I know what that is? Nope, it asks me how many liters of solution. And so that's going to be my x right here. So I have x liters down here. And so to solve this, I'm going to multiply x up on both sides to start with. And then as soon as you do that, that nicely cancels off our x's down there. And so we are left with 0.45x equals 1.1. Want to divide both sides by 0.45. That's a 5 down there. And so in doing so, if you put in the calculator, 1.1 divided by 0.45, that gives you 2.444, repeating. Okay? Significant figure-wise here is that, taking a look, we have how many liters of 0.45 molar? That's got two significant figures. Or made with 1.1 moles, that's got two significant figures. So our answer should be rounded to 2 sig figs. And so in this case right here, we would get 2.4 liters of our solution would be our final answer. That's how you'd go about using molarity. Okay? How many grams of NaCl, sodium chloride, must be added to 400 grams water to produce a 4.5 molal solution? And so in this case right here is that we know we have a 4.5 molal solution. A molality, remember, is equal to the number of moles of the solute. Solute here is NaCl. We don't know that, so that'll be X over the number of kilograms of solution with kilograms of solute. The solute here is water, and so we have 400 grams. That would be 0.4 kilograms there. And so to solve for x, we're simply going to multiply up 0.4 times 4.5. So 0.4 times 4.5 gives us 1.8. So I know I have 1.8 moles of NaCl. Question asks for, though, how many grams. So I'm going to want to set this up in my table. So 1.8 moles of NaCl. I want to get rid of moles. I want to go to grams. And so in this case right here, we go back to our periodic table. We look at sodium, Na, it's 22.99, plus chlorine, which is 35.45. And so when you add those two up, we get 58.44. 58.44, and that's in 1 mole. So 58.44 times 1.8 divided by 1 gives us 105.92. 105.92 grams of NaCl. Significant figure-wise, taking a look at this, we have a 4.5 molar solution, that's 2 sig figs. 400 grams has 1 sig fig, and so this would simply round to one significant figure. 105.92 just rounds to 100. So I have 100 grams of NaCl would be my final answer here. The number of grams of NaCl needed to create 400 grams of, or added to 400 grams of water to produce a 4.5 molal solution. One last one here. If we have 1.4 moles of KCl, they're added to water, the resulting solution is found to have a mass of 750 grams. What is the solution's molality? And so in this case right here is that we're looking for molality. And so we'll go ahead and set this up, and so we say that molality is equal to the number of moles of your solute. Solute here is KCl. We know we have 1.4 moles of that, divided by the number of kilograms of solute. Sorry, kilograms of solvent. And so in this case right here, we know that the solution has a mass of 750. We do not know what our water has a mass of. So we're going to have to figure this out, because what we know is the solution is 750. And so if we could subtract off the solution, the mass of KCl, then we know how much water we had left. But the problem is right now we're in moles of KCl, so our first step here, and this one is about as complex as they get, is we're going to start off with 1.4 moles of KCl. We want to go ahead and we want to convert that from moles to grams of KCl. And so taking a look at our periodic table here, because that's how we convert from moles to grams, we see potassium has a mass of 39.1. So we take 39.1 plus chlorine, which we look up and we see is 35.45. That gives us 74.55. So 74.55 grams in 1 mole. 74.55 times 1.4 gives us 104.37. So we have 104.37 grams of the potassium chloride. Now, since we have 750 grams of the solution, when we have 104.37 grams of potassium chloride, if we subtract those two, 750 minus 104.37, then that gives us 645.63. So 645.63 is the number of grams of water. So we need kilograms of water, though, and so to go from grams to kilograms, we once again move the decimal place over 3 spots. And so in this case right here, I'm going to get 0.645 kilograms of my solvent. And so to find the molality, I take my number of moles of KCl, 1.4, divided by my number of kilograms of solvent, which is 0.64563 if you want to take it out the whole way. And so I get in this case that we have a 2.168 molal solution. 2.168 molal solution. Significant figure-wise is that we have 1.4 moles KCl, that's 2 sig figs. I have 750 grams, that's 2 sig figs. So I know that my 1.4 on top has 2. For my guy on the bottom, the 0.645, is that in order to do that, I had to find the number of grams of the KCl first. And that should have 2 significant figures. So that means this guy right here is rounded, has 2 sig figs right here. So the 1 and the 0 are significant right there for each one. Then when I subtract that from 750, that's the tens place. This guy right here is the tens place. That means my answer should be around the tens place. So 6 and the 4 are significant. That means this guy should have 2 significant figures. That means I've got 2 for both of them. My answer should have 2. So that means my final answer here would be 2.2. And so I have a 2.2 molal solution for my final answer here. And so the solution's molality, I have a 2.2 molal potassium chloride solution.